So slide number 8, it's better you open it from the PowerPoint, okay? Or number 12, sorry.
Yeah.
Number 13 even. Okay. So these are functional or functions available in signaling. We have supervisory. It is used to determine if a needed resource is available and then seize it, and also to communicate the status of the resource. Then we have address. Address, you know the address, identify the resource. We have call information, refers to those signals that provide information to the subscriber about the status of a call. They are audible tones that can be heard by the caller on an operator with the proper phone set. What you hear when you open the line, you will hear some tone, right? Where is this coming from? The telecom company. Control signaling. Then we have, of course, network management for maintenance, troubleshooting, and audit and accounts for billing. Any questions?
No.
I strongly recommend that also you read the comments here. Part of what I explained is already mentioned here. So now we learned about circuit switching. Of course, this was old technology. With the internet, we needed fast communication. Millions of people, they want to use the telephones and internet. So they invented packet switching. Why? Because, let me go back here. So why it's not coming?
Stop sharing and share again.
Okay, thank you. Because there are some disadvantages of circuit switching. One of them is in a typical user host data connection, much of the time the line is idle. Remember we said the line is dedicated. When you establish connection, the line is dedicated, right?
Yes.
So nobody else can use it. And we are not talking, but the line is still engaged. So it's not practical. Also in a circuit switching network, the connection provides for transmission at a constant data rate. But actually when you are browsing the internet, sometimes you are downloading, sometimes you are uploading, different speeds. Okay? So the solution is to use packet switching, and we will see the videos. The use of packets. Data are transmitted in short packets, and a typical packet length is approximately 1,500 bytes or octet. So this is the standard. And each packet contains a portion or all for a short message. If you have a short message, it is all in one packet. But if you have long message, you divide it into chunks, or we call it packets. Okay?
Divide it into 1,500?
Yes, each. The control information at a minimum includes the information that the network requires to be able to route the packet through the network. Remember, we said in the IP, you will have the source and destination IP addresses. For example, here, I have this computer using packet switching. The data is coming from the application to the transmission to the network layer. It is divided into packets, and in the packet I will put some control information. These control information are source IP address, destination IP address, and other informations. Also, packet switching has two types: datagram approach and virtual circuit approach. In datagram approach, packets could take different routes. In virtual circuit approach, packet takes same route. Look here. Datagram approach here. Look here. I have data. It is divided into 3 packets. But each one, look here, they are taking different route, correct?
Yes.
When they arrive, then we reassemble them again. This is called datagram approach. In packet switching virtual circuit approach, we use the same, they all use the same path. They use the same path. Okay? So a pre-planned route is established before any packets are sent. The node need not make a routing decision for each packet. It is made only for once for all packets. So these are the difference between virtual circuit approach and datagram approach. Yes.
Doctor, I have a question regarding to the virtual circuit approach.
Yeah.
So when it's sending the data, the packets, does it send it in the best route possible? Or
No, the route is pre-planned.
pre-planned? Okay.
Yeah, pre-planned.
Okay.
Based on the best route, the fastest or the most efficient, it's pre-planned.
Okay.
So in summary, here we put together the advantages of packet switching and the disadvantages of packet switching. Very important. Summarizing them, please read it. Give you a couple of minutes. Try to. Usually they are coming in exams and questions. You know. Ask me if you have a question, if something is still not clear. One of the disadvantages of packet is jitter. It is the overall packet delay, okay, because we have many equipments in the middle. Remember, we have switches, routers, and so this cause some delay. We call it jitter. Also, packet switching needs the technician to be more trained, because he needs to learn networking.
Doctor, there's
Yeah.
one point in the advantage when it says when traffic becomes heavy, packets are still accepted.
Yes, when your network is busy and you want to send email, still when you do send, it is going, but it will be buffered somewhere, right?
Yes.
That's the meaning.
Okay.
But if you want to call someone and the line is busy, خلاص, you cannot make the call at all.
Yes.
Okay? Clear?
Yes.
We can come back to this slide later, no problem. So businesses rely heavily on the public telephone network and related services. We have also, other than public, some large organizations, they have their private networks. Okay? Like for, let's say, for a company that have branches and they have budget. Okay? And they have a lot of calls between their branches and head office. They can have their private network. We can also use voice over IP, VoIP. Here uses a packet transmission approach over internet and intranet for speaking, for talking, for audio communication. So in summary, these are the options for wide area networks for data. Okay? Again, I will go here. So these are, I call them the flavors, or you can say the options. We have public packet switching network. When it is public, it is cheaper. Public means it's provided for everyone. And we have private. Private means that
It's only for the people who are.
it's the owner. You have owner, organization. So you own, you have full control. We have also private lease line. Private lease line that I also have the line dedicated for me, between me and my branch. Of course, it will be more expensive. No switching. Okay? So, but then I will make sure that I have my cable is dedicated, lease line is secure. Then we have public circuit switching network. Remember we said this is the old technology. Even private circuit switching. And then we have ISDN. ISDN here, interesting because it offers both packet switching and traditional circuit switching. Okay. Go back there. Yeah, this is what I was about trying to tell you that for internet, when you are the traffic or data communication is coming into two categories. Either it is a stream traffic, where you have lengthy and fairly continuous transmission, like file transfer, telemetry device that is measuring some like pressure or maybe fluid flow. So you have constant data coming, constant speed. Okay? Or you have bursty. Bursty, short, but sporadic transmission. Yani like when you are browsing the internet, you click, when you click, you start downloading. So the traffic is high. Once it's down, it's low again. We call this bursty, like burst.
So doctor,
Example is fax transmission, interactive client server traffic. Yes.
so I wanted to ask, so when we're browsing the internet, so for instance, if we visit a website, a web page, it
Bursty.
goes to us, and then it goes to stream back, right? Or no? It
No,
just opens up?
it's still bursty. You are in the bursty.
Hmm.
Bursty, and in general, what kind of communication is this? Bursty.
Pop-up bursty.
Yeah. Is it clear?
Yes.
Okay, let's go back to voice over IP. This is important topic. What is voice over IP? It is a transmission of speech across IP network or the internet. It works by encoding voice information into a digital format, which can be carried across IP network in packets. Advantages over traditional, of course, it is cheaper, correct? And also you can integrate it with other services, such as combining it with data, with other traffic. You can combine it. But you need to give priority to VoIP. Here is the diagram here. We have a subscriber calling another party. So here Alice using data compression and then the packetization protocol RTP. Okay, and then it is sent over IP, over the internet. Okay, when it arrives, you see here UDP. We are using UDP. You see here, why UDP? Why not TCP? Remember we said this last time, UDP is faster. Okay, so what is the packetization protocol for VoIP? RTP. VoIP context. There are some telephony infrastructure for VoIP. We cannot just use VoIP in any network. We have to have VoIP PBX, VoIP enabled computers. Then they will connect with the PSTN or public switch telephone network, and then they can call traditional telephones. Okay. So to fix this and make it work, you have to coordinate with the telecom company. Otherwise, they will not allow you. Like I'll tell you an example. Can you use WhatsApp to call a landline?
No, no.
No. These are some of the end user products for VoIP. Traditional telephone handsets, conferencing units. Let me open it here, is better. Yeah. Traditional telephone handset, corded or cordless, some of them, or conferencing units. Okay. Used in the conference rooms, or mobile units, like smartphones and other cell phones with VoIP capability. And soft phone. Soft phone is a software you install on your laptop to act like a telephone. Okay? And you can dial the number from your laptop instead from your telephone. Okay.
Application from Intel.
Yeah, soft phone. We call this application soft phone. Cisco also they have. All right. Any questions? switching, this is the summary. Please read the summary. Well, I'll take the. I think some people came late, right? Who came late, please? First, Ahmed, Abed. Hamad Abed. Who else? What's your name? Maria Mansour, okay. Wait, please, wait. Who else? Arim, okay. Arim Ahmed. Okay, you can have a short break now. What's your name? أي ساعة جيت؟ وربع؟ بعد الصلاة ما كنت معنا بالمسجد أنت ولا؟ ما حطيتك متأخر، حطك متأخر ما حطيتك. لا ربع ساعة عشان الصلاة عادي.